cellular wireless network is characterized by a few important characteristics, like bandwidth, peak data rate that we can use, the type of spectrum that we're going to be using, which is ever going up the spectrum ladder, the type of architecture we expect to see, and the service types. Again, it's with the benefit of hindsight that we can actually try to make some conclusions about how 6G will be looking like. If you think about it, from 2G to 5G, we've been going up the bandwidth ladder quite dramatically, from hundreds of kilohertz or very small amount of bandwidth to hundreds of megahertz now actually deployed in 5G. The 5G devices can easily handle up to, let's say, 800 megahertz of bandwidth. In 6G, it is going to be an order of magnitude higher. We were talking about tens of gigahertz of bandwidth. Our channel is just going to be enormous, and this needs a lot of interesting challenges also to be met, like how do we share this spectrum if we have to, and how can we actually make hardware that efficiently makes use of this extraordinary amount of bandwidth. The other thing is the peak rates. From tens of kilobits per second, nowadays, a gigabit per second is a reality. I get that occasionally on my own 5G device when I go on doing speed tests. I see a gigabit per second now and then, not very often. But in 6G, if you want to break the threshold and go beyond what 5G and 5G Advanced can do, we need to get to terabits per second. So our peak data rate should be in the order of terabits per second or higher in order to break the boundary with 5G. When it comes to spectrum, we have been all over the place, especially with 5G. We did a very important leap in terms of spectrum where we jumped into millimeter wave domain, and now we're looking at terahertz spectrum. I shall come back and talk about the importance of terahertz spectrum as we move forward. So this is has its own challenges, and one immediately, if you have an RF engineering background, the first question that comes to your mind, my goodness, does this mean that my phone and the base station should be just 5 feet away from each other? And there are interesting solutions that people are working on to actually remedy this. The next thing is architecture, from circuit switch to a combination of circuit switch and an IP world, to a decentralized radio access network, and now virtualization is all over the place, both in the radio access network and the core network. 5G is going to have all of that, 6G is going to have all of that 5G has in terms of virtualization and cloud native deployment, but we're going to see more of an artificial intelligence based network operation and cell-free networks. I shall come back and emphasize this work. What on earth is a cell-free network that 6G might benefit from? It's not as mysterious as you might think. We still need cells, but the way things work are going to be quite different. And finally, services. That's probably the $64,000 question. What's going to be the killer app of 6G? And like I said, very interesting developments recently tell us that we potentially are going to see immersive communication as the first use case, maybe first in 5G Advanced. Actually, if you look at the specifications, immersive communication is getting top priority on 5G Advanced forums. But in 6G, we're going to see more of that, and probably something called HTC, or holographic type communication, which I hope I can convince you is not just a gimmick and goes beyond what we can do today in terms of communication.